HTTP response splitting is a bit of an obscure risk, and frankly, it's not one that we see very often on the web today. But it is a risk that you'll often see referred to in material on hacking web servers. So I want to make sure that I explain it here, and then I'll also explain why we don't see it too much. So let's take an example. And here we have a piece of code that's setting a cookie. Now this code is in C#, but the language doesn't matter. It's the same concept regardless of the framework. And what's actually happening here is on the first line, we're looking at the email value that comes in from a form. On the second line, a cookie is created. The name of the cookie is email, and that value from the form is set as the value of the cookie. On the third line, the cookie is set in the response and returned to the browser. So what this would effectively do is lead to a response header that looks like this. This is simply setting the cookie called email to the value that was in the form, so theoretically my email address. Now there's actually a little bit more to a response header than just setting a cookie. More specifically, a response header typically looks like this. So here's the key thing. We've got the HTTP version and the response code here on the first line. The ellipses indicate that there may be other response headers. They don't matter too much for this example. And then we have the email address set in that cookie. So the important thing of note here is that HTTP response header and the cookie. Now let's talk about how response splitting actually works. So let's imagine that the cookie that was being set looks more like this. Now inevitably, this value would have been passed in the form variable named email. Now it starts off the same, it's my email address. But after that we have some URL encoded characters. And what we're actually looking at here is a carriage return, that's the %0D, followed by a line feed, that's the %0A. Just simply encoded, that's all they are. Now after this, you can see that HTTP header set again. There's the version 1.1 with a 200 OK. And then following that, we've got another CRLF, another carriage return line feed. Now imagine what this looks like when it gets appended to the rest of the header and those encoded characters are decoded. It'd look like this. Now what we're actually seeing here is really two responses, because each time we start with that HTTP version, that is the start of a new response. So by passing this carriage return line feed in the request and then having that reflected in the response, the attacker is able to split the response. Now not only are they able to split the response via the header, they could now append their own body. If they can append their own body, it means that they're able to write their own response. So what we're actually seeing here is analogous to a reflected cross-site scripting attack. That is, input from the user is modifying the response from the server, and doing so in a malicious way. Now there are a bunch of things that need to fall into place for this to happen. So one is that the server actually needs to accept these characters in the request. And many will reject it. This is one thing about modern frameworks. They're getting much better at knowing what is malicious activity right out of the box. The other is that the application has to actually reflect that untrusted data, so that is the email value, back into the header verbatim. And what I mean by verbatim is it will take that CRLF and add that precisely. It won't properly output encode it. And output encoding is something that I speak extensively about every time I talk about XSS. So you'll see XSS in ethical hacking, hacking web applications, and in that course I just mentioned, the Hack Yourself First How to Go on the Cyber Offense one. The key thing is that most applications now, by default, will encode those response headers. So an attack like this becomes very difficult, because the CRLF cannot effectively end the existing response and add its own response, that additional split response. Not only that, but most frameworks also won't allow the raw response header to be written. So that is, it will allow you to add your own response headers, but it will encapsulate them one by one. It won't let you break out of it and actually end the entire response header and start a new one. HTTP response splitting does not feature in any of the major web security lists going today. For example, you won't find it in the OWASP Top 10, the canonical list of web application security risks. But again, I did want to cover it here because it does feature when you see information on ethical hacking of web servers. So that's how it works. You see it very rarely today, but at least you now know what it is. Further to that, let's go and look at web cache poisoning, because that's a bit of a similar situation.